Welcome to tonight's video on probability. First, we're going to talk about how to differentiate between a combination and a permutation. A combination is when order does not matter. The formula for combination is n factorial over n minus r factorial r factorial. However, you do not need to know that. I'll show you how to type it in your calculator. Possible combinations taken two at a time where order doesn't matter. So for example, TV, TW, TX, VW, VX, WX. So notice there's 6 combinations. The order doesn't matter. VT and TV are the same. So here I would have smiley face, sun, smiley face, heart, I can't draw, smiley face, triangle, and then I would have sun, heart, and then sun, triangle, and then heart, triangle. Those would be the 6 combinations. So to do a combination on your calculator, you would just type it. You'd go, first of all, you'd hit the first number. So you hit 20, and then you go to math, and then you go over here to probability, and then you see number 3 is NCR, that means combination. You hit enter, hold on, and then you type in the number, the next number, which is 15, and then you hit enter. Hold on, let me get it. There you go. Then you hit the next number and you get 15,504. So let me do one more and then we'll skip some. So like 16C10. So when you type that in on your calculator, you're going to go 16 math and then number probability, number 3. So then number 3, let me scroll down, hit enter, and then 10. Oh, no, 0, 10. Sorry, I have to move the calculator around to get it to work. So it gives you 8,008 different ways. So that's the number of ways that you could do 16 things, taking them 10 at a time. The next concept is what's called a permutation. So a permutation is when order does matter. So for example, TV, TW, TX, but then VT is different because the order matters. VW, VX, then WT, WV, WX, then XT, XV, XW. So the order matters. So notice there are 12 different ways to do this when the order does matter. All right, for the permutation, the formula is n factorial over n minus r factorial. So when you do 6 permutation 6, meaning you have 6 things and you want to order them 6 at a time. Hold on, sorry, get the calculator. You go 6 and then hit math then over to probability again, and then number 2 is permutation, and then 6 again, and then hit enter, and you get 720. So there's going to be less combinations than there are permutations. So if I did 5 permutation 4, notice 5, math, and then over to probability, and then number 2 is permutation, and then 4, I get 120. So now we're looking and we're going to state, is this a permutation or a combination? There are 15 applications for 3 jobs: programmer, software tester, and manager. So this is where order matters, because it's different to be a programmer than a software tester than a manager. So this would be a permutation. And to find the different possibilities, you'd go 15 permutation 3. So you type it in your calculator, 15, let me clear, 15, and then math, over to probability. Number 2 is permutation, and 3, and you get 2,730 different ways that you could choose 15 applicants for the 3 jobs. So if you have a group of 20 people that are going to run a race and the top 5 finishers advance to the finals, the order doesn't matter as long as they finish in the top 5, so therefore it's a combination. So you would go 20 combination 3, or sorry, combination 5, because you're finishing 5, top 5. So we go 20, math, probability, number 3 is combination 5, 15,504. All right, you can do the next 2 on your own and check the answers online. Let's move to some other ones. Like number 17, you're setting the combination on a 4-digit lock. Now, even though it says combination, think of your locker. The combination matters, like 5, 12, 20. That is different than 25, 12 when you use your locker. So this is a permutation. And you would choose 4 numbers in 4 different ways. So you get out your calculator, 4, math, probability, permutation 4, and you go 24. A team of 8 dodgeball players needs a captain and a co-captain, so it matters captain and co-captain, so it's also a permutation. 8 permutation 2. So you go 8. Let's clear that. So you go 8, math. Number 2 is permutation, and then 2. So it's 56 different ways. For something like this, 4 out of 16 students will ride in the van or in the car instead of the van. That's a combination, because it doesn't matter the order that the 4 are chosen, just that the 4 ride in the van. So it's 16 combination 4. And you get 1,820 different ways. All right, so now we're going to do some probability. So there are 8 nickels and 4 dimes in your pocket. You randomly pick a coin out of your pocket and place it on the counter. So you're putting the coin away. Then you randomly pick another coin. The first coin is a nickel and the second coin is a dime. So on the first coin, the probability of getting a nickel is 8 out of 12. Then you're going to multiply, because it says and means multiply. The second coin is a dime. Well, now there's only 11 coins left because you took the nickel out, and 4 of them are dimes. So 8/12 times 4/11 will give you 1/3. So 8 out of 33, which, if you want to make it a percent, you can go 8 divided by 33. And you get 24% approximately. All right, let's look at number 23. Number 23 is an example where you put the item back. A basket contains 5 apples and 6 peaches. You randomly select a piece of fruit, then return it to the basket. So what's the probability both fruits are apples when you select them? So you have 5 apples and 11 total pieces of fruit. And then you're going to choose again after you put the apple back. So once again, it's a 5 out of 11 chance. So it's 25 out of 121. Which is a 21% chance, approximately. The next one down here, a gambler places a bet on a horse race. To win, he must pick the top 3 finishers in the order. 8 horses of equal ability are entered in the race. Assuming the horses finish in a random order, what is the probability that the gambler will win his bet? Well, there's only one way to win, and that's if the horses finish first, second, and third. And it says, assuming the horse... so now you got to figure out how many different possibilities are there. Because remember, probability, as we've been talking about, is successful outcomes over total outcomes. So right now there's only one successful outcome, but how many total ways can 8 horses finish first, second, or third? That is a permutation. So you go 8 permutation 3, and you get, so you're going to go 8 permutation and then 3. Sorry. So you get 336. So it's 1 out of 336, which as a percent, is 0.29% or 0.3%. So not a very high chance that that happens. All right. So the colors of the rainbow. Using a box of 10 different colored crayons, which include the 7 required colors, after drawing the red, orange, yellow, and green arcs in the proper order, she forgets the last 3 colors. From the remaining 6 crayons, she chooses 3 at random to finish the drawing the rainbow. What is the probability she correctly finishes drawing the rainbow? Well, there's one way to do it. And it's a permutation because the order matters. So you're going to take the 6 crayons and choose 3 at a time. So remember, on your calculator, you're going to go 6 and then math, permutations number 2, and then 3. So that means there's 120 different ways that she can choose those crayons, and 1 out of 120 makes it approximately 0.8% chance. All right, so go ahead and practice the other ones on your own, and you can check the answers online. and have a good evening.